concept, that is object oriented analysis and design, in short OOAD. Now, in this particular concept, I mean, we shall be covering the following topics. First is the general concept of what is object oriented analysis and design, and the object oriented analysis and design concepts are intertwined with the concept of UML, that is the Unified Modeling Language. So, a rough idea of object oriented analysis and design along with the concept of UML. Then we shall go directly to the modeling aspect of object oriented analysis and design. The very first one is the use case modeling, right. See, the idea of use case modeling is different from your traditional data flow based model, right. The basic idea of an use case is like a business process. So, you have to see the idea of an use case purely from the view of an user, right. So, essentially the use case model depicts the use case and the actors. So, we will go into detail later on. Then we certain other things about the object oriented analysis, how exactly from the use case you go ahead with the analysis part of the thing, how you basically design the class, the attributes of the class and the operations that are associated with a class. Then the design of the class design, right. So, when you have a number of classes in a particular system, information system, how the classes are connected to one another and how they together create, let us say, a class diagram or a VOPC, that is called a view of participating classes, right, VOPC. So, this is the thing. Then on the other side you have the behavioral modeling. Behavioral modeling means, okay, we define the classes and what are their attributes and their operations, but when it comes to operations, how the operation of one class is connected to another class. You see, that is where is the major departure from process based thinking. The basic idea of the object based thinking and the process based thinking is, in a process based thinking everything happens according to a process logic, whereas in object based thinking you assign objects with behavior, right. So, it is like there are two students, let us say, take a simple case of two students are fighting amongst one another, or two children are fighting basically. So, in a process based logic you have to give the entire logic. For example, if one boy kicks the other boy, then the other boy will react in two ways, all right. So, what are the two ways? If he goes for this, what are the likely outcomes of the other boy? So, you have to think of the entire sequence of fighting and essentially put down that in the form of an if then else logic, all right. Whereas, in object oriented thinking you have to think that this is one boy, he has certain attributes, he has certain behavioral patterns, all right. So, if he does this, he does this, he does this. On the other hand, the second boy is also another boy, he has an object, he is like an object and he also has certain operations, he does certain thing. Then you have to go for the behavioral modeling in the sense how these two boys, when this boy does A, what the second boy does, all right. So, then you define all this, but the actual fighting between the two boys will come out of these behavior patterns. What exactly will happen, that will probably be dependent on perhaps the random number chosen by you. If you are simulating it as a discrete event simulation model, then that is the thing. So, the developer himself does not know what could be the outcome of this particular let us say the fight sequence, right. So, this is a trivial example. Let us take a slightly better example. Let us think about a runway, right. So, a runway sometimes like a Mumbai airport, you might have some idea that it is a very busy airport, right. Therefore, the runway is also heavily utilized. So, sometimes the planes have to wait, alright. Now, if you want to simulate this particular runway, what you can probably do? You can define the runway, what is a runway, right, what are its attributes, and what are the conditions for a plane to land. Under these conditions, if the runway is free, there are not more than, see, runway is a very large one, and therefore, if there is only more than 2 planes in the runway, then the third plane cannot land. Suppose you define this, that at a time there should be only 2 planes. If there are 3 planes on the runway, then another plane cannot land in the runway, alright. Similarly, for the plane for plane to land, it has to fulfill certain conditionalities, right. It has to arrive at the destination, it has to reach certain height, it has to see the weather is clear, and all these things. Okay. So, now exactly whether what will be the, see, you may have some sort of behavior pattern, that if it is raining, right, and the runway is not free and something, then the plane has to wait. So, you have all these conditionalities very clearly given, alright. Then you just let it happen, you generate certain planes, you generate an initial condition of the runway, and then you start simulating. What exactly will come out of this is not known, right. So, there is no need to write a sequence of if then else logic when you try to go for an object oriented design. In another sense, you can think of an object oriented design is like is a huge menu system, right, like working in Microsoft Word. What is happening? What you will be doing is your choice, everything is there in the menu. You write something, you want to make it bold, you press the bold icon. So, a bold icon is as an object. What is a bold icon? It is nothing but an object, alright. So, this icon has got certain attributes, it looks like something, a B will be written on that in capital, etc., and it has got certain operations. What are the operations? That is, it makes the text highlighted bold. Okay. So, these are the things that we shall be discussing. To begin with, let us discuss some little bit of history about object oriented analysis and design. See, obviously, before we come to the Jacobson, Rumberg and Buch, the concept of object orientation is as old as humanity, alright. Basically, it is surprising that people did not think of object oriented design first, rather than thought about process logic first, alright. This is because, see, when let us say a child first learns anything, how do they learn? Basically, they learn to associate certain conceptual thing to the given objects, right. Something like let us say a toy car. What is a toy car? The toy car to a child is something that looks like some car, has got some color, attractive color, has got 4 wheels, and it actually runs, alright. So, the child will associate the car with these things. Okay. So, these the basic learning process is basically trying to see a number of objects and try to assign certain attributes and operations to them. Okay. So, this is how the basic learning itself goes. So, in that sense, object orientation is nothing very new. It was surprising that people did not start with it in the first place. Now, although I have only put Jacobson, Rumberg and Buch's name, actually the development, there are many other people such as Codd, CODD, right. Codd has done a substantial amount of work towards object orientation in the 80s, alright. Now, during that time, the basic problem that arose, that there are so many methods. For example, we have the object oriented software engineering OOAC by Everett Jacobson, the object modeling technique OMT by James Rumberg, object oriented analysis and design by Grady Booch, the Booch method. So, you see there are so many methods that people were confused. It is not that they are differing too much, there is definitely lot of commonalities amongst all these methods, but nevertheless there is lot of differences in notations, So, what the object management group did, the OMG brought all the three people together, right, the Jacobson, Rumberg and Booch, and together they started a new concept called Unified Modeling Language or the UML. All right, please understand the UML is not really a concept, UML is a notational language, right. It is an notational language. Basic idea of UML is it gives you a notational approach, a standardized notation to write object oriented analysis and design diagrams. All right. So, as a concept we still call it object oriented analysis and design, but UML could be used to denote the diagrams. That is the basic idea. Is it clear? So, since UML has become the de facto standard, see why de facto, because OMG, it is not that everybody has formally or legally agreed that this is the formal standard. It is not a formal standard in that sense, it is an de facto or informal standard of object oriented analysis and design as on today. Right. Very recently UML2 has also been released in 2002 or 3 I think, and these UML2, I mean differences are very little, but nevertheless the latest standard, if someone asks, we can say as a UML2 and not really just UML. Before going to the basic concepts, let us see a little difference between your structured system analysis and design method SSADM versus object oriented approach. Once again, basically in SSADM we break the problem domain into processes, examining the behavior and modularizing the behavior into functions. Okay. Whereas, in object oriented approach we identify the objects in the problem domain and classifying them in terms of data and behavior. So, you see what is happening in structured system, the behavior is modeled into functions. What about data? We do not talk about the data in the process based approach. The data is used separately in what is known as the data modeling. So, that is what I have explained in great detail, that structured system method has got two components. One is the data flow modeling, basically modeling the processes, and the data modeling which models the data. Whereas, the object oriented approach couples both the approaches, the data as well as data flow. So, it models data and behavior and put them together in objects. One can ask why, what is the advantage, and if possible are there any disadvantage? The advantage is when you put the data and the behavior together into the forms of classes or objects. Can you tell me what is the biggest advantage? So, what? See, he has said encapsulation. Encapsulation will explain what encapsulation means, we will go a little later, but whether it is encapsulation or not, the basic idea of doing this is basically have the advantage of rework. See, reworking is easier, much easier. All right. So, reworking is much easier, reuse is possible, right. So, that is the basic advantage. Great advantage in reworking and reusing. See, moment you define an object or a class in a very generalized sense, these object or the class or these particular class, let us say, I think I must tell you the difference between class and object, right. A class consists of a number of objects. So, if I say an employee is a class, then an individual employee is an object, all right. So, if S Das, D Shur, P Reddy are 3 employees, then we can say each of these employee are actually objects and together they constitute the employee class. Is it okay? So, that is the thing, between individual objects there will be differences. So, when we talk about class, we talk about attributes. Attribute is name. All objects will have a name, but the name could be different. One object may have name P Reddy, another object may have another name, all right. So, that is the difference between classes and objects. But when it comes to the conceptual thing, we do not use the class word very much, but when it comes to implementation, we must understand that there is a big difference between class and objects. So, identifying the objects in the problem domain, classifying them in terms of data and behavior, that is the basic idea of object oriented approach. So, okay, I was talking about the reuse. So, reuse is the basic advantage of object oriented analysis, and why? Because if you could have very specified class libraries defining the specific uses of a particular thing. For example, if you define a menu class, what is a menu class? The menu class essentially pops up a menu of variable number of items and you can click on one of them. Think about it, these menu class you can use almost in any application, all right. You have taken care to see that menu, the individual, the color to the menu, to some extent maybe shape and size, and also the number of menu items can also vary, you can vary. So, this generalization has been actually done. So, if this is a separate library, if you are having another application, you do not have to write this menu class again, you can simply reuse that menu class. See, this is the basic advantage, that you can have reuse. In fact, reuse and component based design, has become the rage of today's. What is component based design? If you have reusable components, for example, the menu is just a single class, but together with few such classes you can design a component, right. For example, a component for window management, a component for a given calculation, right, maybe the facility location calculations. So, all you have to do is put together all these components and then develop a little bit of your own to bring or develop a customized software, right. So, what happens? Your development time reduces, you are dependent on certain kind of developers, expert developers in a certain area reduces, all right. These are the basic advantage of object oriented analysis. On the flip side, what is the flip side of this? That you can do lot of things, but for that you require expert people, trained people, right, people who really understands object orientation. Slowly after the initial euphoria is over, people are being increasingly aware that object oriented analysis is not a very simple thing. It is not a very simple thing. It requires a little bit of maturity. The people should be well trained, and if you allow someone who does not understand object orientation much and he wants to go for object oriented design, most likely he would come up with something which is as bad as the process based design. Process based design, the advantage is it's going on for a long time, there is a lot of expertise available with people, all the old systems are developed through the process based thinking, alright, because you see you cannot throw away all that has been developed so far, alright. There are thousands and why thousand, millions and millions of dollars have been invested into information system, into the hardware, and important applications are running on them. Think about a large company running their payroll of 50,000 people in an application developed by using process based logic. Now, will you throw the application and say because it is not object oriented we would not use it? You cannot do that, because it again requires lots and lots of investment. Why should people invest for something which is already there? Alright, the payroll is working, everything is fine, people are getting their pay slip, because end of the day that is more important than application, is it not? What is the purpose of the application? To see that the payroll process runs in a very smooth manner. Is it clear? So, this is the great challenge, all the more for India, because if you really look at the Indian scenario, a large chunk of the software consultancy that India gets are essentially in the domain of your maintaining old systems, transfer of a system from one old system to another new system, basically no change in the application, simply you are porting the system from one system to another. Alright, these are the kind of jobs, I am not saying these are the only jobs India is getting, these, but this is a substantial part of the job that India is getting in the name of software consultancy. Alright. So, naturally speaking, you have to be aware of all the techniques and technologies which have been not only being used today, but has also been used in the past, right. For example, COBOL, the COBOL programming, everybody thinks there is no future of COBOL, but nevertheless who knows, you might be in a project if you join a software company where COBOL is being used, alright. So, these are the pros and cons, and one should be very aware that what is the advantage that you are getting, alright. Some systems are very process oriented, where even if you do object orientation, probably not much to be gained, alright. Whereas, something which basically you see object oriented approach basically is an offshoot of the data approach, the data modeling approach. That is what I said while discussing the database management systems, right. So, anything that requires a high involvement of data, high involvement of a database, and that is the major application, not the process logic alone, right. Naturally, object orientation analysis and design will be the appropriate approach. Now, when it comes to an object is something that exists within the problem domain and can be identified by its data and or behavior. So, example, a student, its data is roll number, name and address, behavior, register for a course, show performance in that course. Okay. So, that is the basic idea of a object. Then the very important concept of abstraction. See, abstraction essentially means that when it comes to a student can have lots and lots of data and lots of behavior, but are we going to use all of that? We are going to use only that aspect of student which are important to us in a given context. Is it all right? In a given context. For example, if say for example, we say that a robot is a model of a person, Now, suppose a robot is just a gripper, all it does it is looks like a hand, it grips certain object like this and it basically throws it, puts it somewhere else, right. It grips something, picks it up and puts it somewhere. So, how does it look like? It looks more like a hand, and we are telling that this is the model of a person. So, does a hand is a person? No, hand is not a person, right. So, basically that particular gripper is not a person, but an abstraction of a person, is an abstraction of a person, right. So, that is the basic idea of an abstraction. An abstraction is a component or a very important part of any object oriented analysis, right. So, that is what. The second important concept is that of classes. So, class is the classification of an object. Like I said, the student, when I say student is an object, I mean to say a particular student, right. Maybe say Shur, suppose S Shur, we have used that S Shur name many times. So, S Shur is a particular student, all right. So, we concentrate only on data and behavior of the student that are important in the problem domain, that is the abstraction. So, when it comes to classes, but all students together, what it represents is a class. The class encapsulates the data and associated behavior. So, you see encapsulation word comes here, it is like a capsule. No? So, if you open the capsule, two portions of the capsule, you find inside the things, the medicines, whatever is available. Similarly, in this case, if you open the capsule of the class, what you shall see is the data and associated behavior for that particular student. Now, why it has to be put inside a capsule? So that it can be separated out from the rest of the objects, all right, and it can be reused later on, that is the idea. So, encapsulation is a process of information hiding. You are basically hiding the information. Encapsulation is a process of information hiding, the data of an object hidden from the rest of the system and available only through the services of the class, all right. The services of the class means, that is the means of communication with other classes in the system. So, how the classes will interact? The classes will interact only through the services of the class. So, every class will have certain services, and this we will discuss how these services can actually be brought about, and otherwise you cannot know anything of the class, right. So, it is like you are a student, unless I tell you what is your name, then you have your services that you tell your name, only then I know your name, otherwise there is no way I can know your name, all right. That is the basic idea. That is the there is a concept of information hiding, the data is inside encapsulated and that data can be accessed only through the services of the class, all right. We will discuss more and more about this, because encapsulation is a very key property of object orientation. You see, we are using so many different words, but we should be careful about exactly which words we are using. For example, we are using the word data, we have used the word behavior, somebody can use the word method, but essentially we shall use attributes and operations for the data and behavior when we are talking about a class. Is all right? The method, the word method is usually to be used when we talk about an instance of the class, for example, an object. So, these are the things that is explained here. So, encapsulated data stored by the class is an attribute. It can only be accessed with the services of the class referred to as operations. So, if you go back to our past slide just for a minute, see, data is hidden from the rest of the system, available only through the services of the class, and the services of the class is the means of communication with other classes in the system. And these services of the class is nothing but the operations. Alright, what is an operation? That provides the services of the class. Through the operations, you can determine the behavior of the class and provide a controlled method of using the class. Right. So, we have the attributes and we have the operations. Then there should be a process by which we can instantiate a particular object of the class, because a class is like a common concept, like a student, individual students are objects. So, how to instantiate? Anybody who has used Java programming, what is the command? How to instantiate a class in Java? What is the command?
Defining a class.
Not defining a class, how to instantiate a class? Yes, the new command, right. So, almost all of you have written Java programs. So, the new command is essentially given to instantiate a class. That means, create a new object, create another object of that particular class. So, then again, for an instance of a class, the operations are referred to as methods. So, you see that is the difference between operations and methods. We talk about methods when we talk about objects, we talk about operations when we talk about the class. Then let us go to the actual thing, that is the classes. The classes usually are represented in the form of a rectangle. The rectangle is to be divided into three parts. Top portion we write the class name, middle portion we write the attributes, and the last portion rectangle we write the operations. So, implementing the class in a programming language, we require the attributes to be private and the operations to be public within the class. See, the private and public is important. The attributes, if you make them as private, what is the idea to make the attributes private? So that they are not accessible from outside, that means they are truly encapsulated. The operations, however, has to be public, because anybody may like to use those. For example, I will give examples that will be easier to understand. So, let us take a car. The car has got let us say three attributes, its make, model and registration number, right. Make as a string, model as a string, registration number as a string, right. So, this car is an class name, these are the attributes of the car. So, I have not shown any operations on the car. Now, operations of the class. So, this is another example, let us say a parallelogram. How to represent a parallelogram? Parallelogram has a height and width and an angle. So, like suppose this is a parallelogram. Okay. So, in this parallelogram we have to have a height, say this is its height, then it has its width, and you have to define an angle. Okay. So, a parallelogram probably can be explained in terms of its height, its width and the angle. So, if you have these three things, alright, you first draw the base, then you put the angle and go up to the point where you reach that height, then rest of the things can be completed. So, if these three things are there, you can construct the parallelogram. Then the parallelogram has got two more things. One is two operations we have defined. One is the calculate area and another is set its width, height and your basically this is like an initialization, right. You can set w to 1, h to 1 as both are integer, angle also an integer, let us say 45 degree, right. So, these are the two functions which are defined for the calculate area. Okay. So, these are some of the what are the operations of this class? Calculate area and set. Now, this is a simple, very simple Java example from Java programming point of view, how this parallelogram can be represented in a Java program. So, what we do? Public class parallelogram, the bracket starts, then private int width equal to 1, private int height equal to 1, private int angle equal to 45, then public int calculate area. See, we have tried to put the operations as public. Actually, when the operations are public, we show a plus sign here. This plus means these operations have a public scope. Then public int calculate area, return width into height. See, it is a very surprising thing, we do not require the angle to calculate the area of a parallelogram, just width and height should be enough. Return width into height, then public void set int w, int h, int a, width equal to w, height equal to h, angle equal to a, right. So, you can set by using the set command, using the set operation, you can set any, see this 1145 has been initialized, but we can use this way to set it to any value. But please understand, our purpose is not to teach you Java program here. I just took out this Java program with the basic idea, if it makes your concept little better, because it should also be clear, more clearer if you, more clear if you also side by side look at the implementation to some extent. All right. That's the basic idea of the classes and the objects. Now, let us see how the relationships between the classes are implemented, right, the relationship of the classes. So, all classes in the system are related to one another, the classes are actually related to one another, and the relationships amongst the classes are basically of three types. The first one is called association, the second one is called aggregation, and third one is called generalization. So, association, aggregation and generalization. The association is basically when two classes are associated to one another in the sense of an entity relationship diagram. Okay. The aggregation is essentially the idea of the whole part relationship, whole part, right, whole part. What is the whole part relationship? For example, let us say a particular assembly, all right. So, an manufacturing assembly, the assembly will how the assembly will be constituted? Probably it constitute some sort of a plate with holes, then some bolts, some nuts, all right. So, we have the plate, we have the bolt, we have the nut, all are part of the assembly. So, we may say the plate assembly constitutes of the plate 1, plate 2, bolt, nut. So, this is like a whole part relationship. The whole is the plate assembly, parts are part 1, part 2, bolt, nut. Is it clear? That is the whole part, that is usually called aggregation. On the other hand, the generalization, the basic idea is that see, we can have different kinds of students, For example, we can have research students, we can have BTech students, we can have MTech students, all are basically students. So, when we call a student, all are students, a PhD student is also a student, BTech student is also a student, MTech student is also a student, all right. But the basic idea of the student as such is a generalization of all these different kinds of students, all right. So, every student will have some common property, like they have a roll number, they will have a name, they will have an hostel attached to. Alright. So, these are the basic properties, but there will be certain attributes of a BTech student will not be there in an MTech student, because BTech students are here for longer time, right. They will be having certain specific things. Similarly, probably a PhD student will be having certain other attributes not usually found in BTech or MTech students. So, is it clear? So, that is the relationship of generalization. In fact, one very basic generalization relationship is the ISA relationship. We have discussed while discussing your entity relationship diagrams. Say we have the pilots and the crew members, both the pilots and the crew members both are employees, all are employees. So, it is a kind of generalization. So, we shall see how these relationships are implemented in object oriented concepts. The first thing, that is the association. An association is a connection between classes showing how one UML class relates to another. See, we are using UML here because everything has been used or shown in terms of UML. And the arrow, and see, when it comes to the arrow has got no specific meaning. This arrow is not the 1:1 I told in the entity relationship diagram, that we draw an arrow on the one side. It is not that way. These arrows simply means the name, how the name is to be read. See, the CD player plays the CD. It is not the CD does not play the CD player. Alright. Since it is the CD player who plays the CD, we put the arrow this way. Suppose you could have written it in the other way round also. So, you may say CD is being played by the CD player. So, if you name it is association name as is played by, then arrow would have been the other way round. Alright. So, do not put much weightage to this arrow. The arrow simply means how to read this association name. Alright. But what is more important is the multiplicity. See, I have told you entity relationship diagram, we use 1:1, 1:m and 1:n. Here I will come back to this slide. The multiplicity is shown in a different way. These are the types or different types of multiplicity that are possible. The first one is an optional one. That means association is there, may not be there. So, it is either 0 or 1. So, it is shown as 0, 2 dots and 1. It could be 0 or more. If it is 0 or more, then we say 0 dot dot star. Otherwise, simply star. 0 dot dot star and simple star are one and the same. Alright. It could be at least 1, that is 1 dot dot star, at least 1. Alright. Specified, a number or range of numbers, that is 2, 1, 3, 7, 10. Suppose a given committee is constituted of 7 members. So, whenever this committee will be formed, steering committee, the steering committee must have 7 members. Suppose it is stipulated. Alright, it is not any, so steering committee to the member cannot be any number other than 7. Right, the steering committee will have exactly 7 members, exactly 1. So, we can just write 1 or we can leave it blank, So, these are called what is known as multiplicity. So, when two objects two classes are associated, right. So, what is the multiplicity? So, let us come back to our previous slide. Between the CD player and the CD player plays the CD. One CD player can play number of CDs, but at a time a CD can be played only on one CD. Alright. So, that is the idea. So, we have the CD player to number of CDs 1 dot dot star, multiple CDs can be played. Look at this, the CD player has got attributes as make and model, and CD has artist and title, right. Whereas, for the CD player we have pause, play, shuffle, stop, and for the CD locate track, CD locate track, right. So, these are the various operations that are actually possible between the CD player and the CD. Then we can have different kinds of associations. One such association is known as the recursive association. What is a recursive association? Where you connect to itself, connect to itself. So, recursive association is where a class is associated to itself. So, it is a kind of self association which is also allowed. The type of association used with linked list. So, basically we have say a number of nodes. So, all the nodes are available, but a given node can actually be connected to another node, is it not? Suppose you have 10 nodes, suppose you define the 10 pages of a book, all right, and say HTML pages. So, each HTML pages you can define as one node, all right, as a different objects. Then if you associate the objects to itself, what will happen? You can go from one page to the next page. Essentially the idea is, if you have instantiated this object, this particular node object, then what will happen? Suppose at a time some 10 objects are associated. So, you can through a previous command you go to the previous object, through the next command you go to the next page. So, maybe a new operator could be given. So, this is called a recursive association, right. In a recursive association, a node is related to 0 or more nodes. Then we have what is known as the OR associations. We have the OR associations. In an OR association, instances of a class may only participate in one of the associations at a time. Okay. In say we have a decoder and we have cable and satellite. The decoder receives cable signal or it receives satellite signal, right. So, we have an OR association. So, OR is written by a dotted line and OR can be put here. Can you think of another OR association example? Say for our internet, how does this internet comes? Either from a landline or through a satellite line, all right. So, you can define it as a satellite or the landline, right, the basically cable, and what you are connecting, the we cannot call it the internet, we can call the signal or you can say the processing, all right, internet facility, you can call internet facility. So, available through both these modes. Just one last slide for today, that is the ordered association. So, an instance of a class is called an object, an instance of an association is called a link. Okay. So, you can also have an instance of an association. Explicit order between the links is shown by putting ordered next to the associated line. The default is unordered. Say a student obtains a grade, all right, a student obtains grade. So, you see you can have multiple students, definitely, okay, and you can have multiple grades as well, but it is important to keep them ordered, otherwise you do not know which grade belongs to which student, because multiple grades are there to a student, multiple grades are there. Suppose there are 4 subjects, the 4 subject grades are available, but which 4 grades are to a given student, all right. So, they have to be kept in an ordered manner. If you simply sort these grades, then everything will be haywire, everything will be haywire. Alright, this is why the ordered associations are important. Fine. So, we have discussed at least one type of relationship, that is the associations. We still have other two to be discussed, aggregations and generalizations. These we shall discuss in our next class.